Hello my dear friends, FPVers, builders, and whoever else watches YouTube. So here's a long promise to some of my friends. The bloody years ago I promised a video. How do I do it? How do I cut my fiberglass? And it's gonna be a long video, so whoever's not interested, I can give up the secret straight on. It's not how you cut it, it's how much time and effort you put in, and how much spending time to refine the parts afterwards, so they look all nice and neat like a CNC. Okay, so was that interested? Make yourself some popcorn and let's go. Okay, so that's from the dinosaur age when the servo gimbals ruled the world, for example. So I just wanted you to know where I'm coming from, what goes towards the technology. So what I'm doing with the fiberglass, I am sunken everything in, and I lighten everything out. This way the structure is very solid and yet very light, and what goes towards the crashes, all these bits, all these parts, if there's a good crash on a copter, they just break off and they just pop out, and they can be stuck on with the super glue again. Needless to say that if you're gonna glue two parts into the T, they're not gonna hold. You're gonna put a lot of bead of a resin with micro balloons that's gonna have a lot of weight, which is a big no-no for me. And I don't do any drawings. I don't do any computer drawings or anything. My Corel Draw and AutoCAD is my pencil, rubber, and a ruler with some compass as well. So the way my brains are wired, if I think of something, of a project or of anything, like just a few sessions in the lieu of brainstorming, and I can see completely 3D image spinning in my head, and on top of that there's a whole list of what to do step by step, and what I have to get materials and this and that. So learn to order stuff from China a bloody month in advance. So from the other technology point of view, the way I find things, finding measurements. Once I have, for example, this is gonna be a brushless gimbal. For my long forgotten project, there's a sort of a QAV 500 size that I was looking at, and of course I don't believe in buying, I believe in building myself, so I can make it better, lighter, and all the other things, like the QAV 500. It's a 500 gram frames. This one's bare frame. It's only 300 grams, and because everything is sunk in rightly with the structure, there's absolutely no slop or no anything. So that's the reason why I'm spending so much time on building my own things instead of buying. So the way I do things, I want to build, let's say, a gimbal for GoPro camera. I have a GoPro camera, so I cut out one plate. On this one particular, my video transmitter will be swinging level with the GoPro. I cut out the plate. I put it to balance with all these connected. So I know from this plate to which point is my balance point. So from that balance point, I leave a little bit of space in there. So I made a motor mount that it's adjustable for the balancing. So when I made the motor mount, I mount the motor. I cut out this plate and then put it again balancing on this axis. After I find where's my balance points on this axis, I measure from that point to this point, so I know what distance is gonna be my plate to the other point. So from that point again, leaving some space for the balancing. So here's how things are working for me. After I'm finding one measurement, I will know what's the measurement, what's the other measurement gonna be, and then the next one, and then the next one, and then the next one. Okay, so that's how things works for me. Let's get back to the working. As an example, I'm gonna show you how. I'm gonna cut one plate here. For example, this is gonna be for a friend of mine, antenna tracker stand. Like the cardboard is represent the cover of a ground station box, and I just made a template to make sure that's a space that I have to there's a space that I have to work with. So I have to come up with with the antenna tracker stand. So if that one's closed, this one folds vertically, and actually you can barely see here, and that one will be unfolding like this. Okay, so the plate that I'll be cutting now is the bottom plate that attaches to the ground station box. And yet again, once I knew the servo dimensions, I cut out this plate that I knew the width, then I knew the length of it by the measurement of the box. Also I knew the height. So one part is done. From that part I can make another part. This is gonna be just a made up screw to tighten up. So when I had these parts, I put the washers in there, there's a threaded in, it's all. So now I know this measurement. When I know that measurement, I can move on with the plate at the back. So I'm gonna show you now how I cut my PCBs now. Okay, right, so knowing the measurements there, I know the measurements here, I can draw out the plate. Now before I cut my fiberglass, I draw literally on this one. It's a A4 paper sheet the office is using to make stickers in there. So alright, so Corel Draw is running. That's a copy pasting. Okay, so I got that one drawn, just double check to fit. Okay, it'll fit in there. It might be a bit of a messy here with the lines, but at least I know myself where to cut and what to do. Now before cutting, I have my files that I'm working with. Before cutting, I don't leave sharp edges. They have to be rounded because there's a breaking point. If it's sharp, it's going to be a breaking point. You have to be rounded. So to help me cut it, I'm gonna drill some holes. Now here's my fret saw, and these blades they only something like 2 mil in width and 0.5 mil, I'd say, thickness, and they don't go in the corners within a 3 mil radius. They can make a turn only, I'd say, bit 5-6 mil. Without going forward and back. So to help me later on, I'm just gonna drill the holes right here in the corners. So all I will have to do is just get the straight cuts, and then we'll go back to refining later. Right, so because my files are 3 mil roughly in diameter, so I'm just gonna get the holes drilled with the 3 mil drill bit. Let's find the 3 mil drill bit. 3.2 will do. Well, as I couldn't be asked drilling the holes of a 1.5 mil, and that is the reason, because the thickness is 1.5 mils, so I'm just gonna use my Dremel tool to cut the holes. Works grand. Right, so all ready for cutting. My CNC aka Lobzik charged. That blade is dead. There you go, and all the way like this. The way I'm going, I am not touching my pencil line, just about, because later on I will be sanding the edges and I will bring exactly to the line, exactly to the measurements. Okay? So I have this one cut off. Now it's left to cut out the enlightenment, so-called, or whatever you call them. There was no need to lighten up these things, because that one will be screwed onto the ground station box, but I gonna make them lighten them just for the sake of the video. Now, because I drilled the holes, the only thing I have to do is just get the straight lines cut, and then I will and then I can go to start refining. So the ones that are gonna be sunk in, they have to be done as well, because I only made a hole so I can squeeze the blade in. So that one's cut out. Looking a bit rough, is it? Well, we can peel it off now, and then we can start sanding it. So the part is cut, rough as fuck. Let's tidy up a bit. Cleaned it up a bit, the straight lines. Now back to the point why I was drilling with a 3 mil hole, because as I said, my file is a 3 mil, so I have to do now is get the round edges done. All cleaned up in here, round edges are done. Now before I move on, I have to check whether it fits my part or not fits. Okay, a little bit not fits. Clean it up. Okay, fits snugly. I'll press it in, and that'll do. Right, so one thing left to do on this one, as you can see, well, you cannot see from camera shine on the close-ups. So there's a sharp edges left in this one, and just in case of I want to go through the wiring in this one to make sure the sharp edge doesn't cut the wiring or the zip ties, I have to sand it on the edge. There's a bit that I missed in here. Right, so taking out the file, and roughly 45 degree. Now, there we go. Everything nice and smooth and the whole lot. Now, this one will be glued on with a CA, and to make sure it gets, well, a little bit more grip, I'm just gonna sand these parts where the CA bead will go. Yeah, like it tight. Now, before I go further on, I'm just gonna visually check for square and where this is all going. Is it all nice and neat? Because once you stick on CA, there'll be nothing you can do except break it off if it's not even or not level or anything. Right, so everything's checked, everything's square and fair and whatever. I'm gonna tack it with CA now. Once it's tacked, it's gonna stay on, and after that I'm just gonna get the line of CA, just a bead of CA all around. So I got the bead of glue all around in here, and I got the bead of glue all around in here. Now it's very strong, so as I said, I left these a bit sticking out because there's gonna be some pressure and there's gonna be rip it off, so it's gonna be just slightly stronger rather than leaving it flush. So as I have these sticking out and this will be mounted to the surface, I have to bring up a bit of a height in there. Okay, so let's get that done here. That little part is done now, so just have to do another bits for antenna tracker, and I will show you at the end what it looks like. And the ginger PCB is not cool fiberglass at all, so yes, Mr. Wayne, it does comes in black. So me hearties, there's my finished product antenna tracker that's supposed to fold up in a case. There you go. Right, so as long as you know now how do I do things, so did it the same way. There's a bearing compressed in there. The supposedly will go I think it's 10 by 10 centimeters, the patch antenna from Immersion RC. So the whole concept was to get, that's the space, as I said, that I had to work in. So it has to be folded in. That will fold nicely in, and the case is closed. No, I don't like that beer. I like Guinness. Bye bye.